welcome to the second part of this interesting lecture. So, we have been talking about supervised versus unsupervised learning. Let us talk in terms of the real machine learning aspects. Supervised learning, one of the ways, one of these techniques is called classification. You know what is supervision? It is a training data. It can be observation, measurements, they are accompanied by labels, remember that. So, if I have a training data xi, label will be yi. What does it mean? For xi, what is the value of yi? That is what it is, and they are part of the set R, training set. So, for every x, I have a y, right? It is like if I heat a metal, melt it down, and then I am trying to find a cooling curve. So, what I need? I need for every time, what is the temperature? So, I talked about it easily, right? So, I have a table, I create a table. So, this is my time t, small t, and this is my temperature. So, every time Ty, T1, T2, T3, I have temperatures T1, capital T2, capital T3 like that, right. So, your label is yi is this, xi is this. So, yi is called label and xi is called observations or measurements, okay. So, that we must have it. So, this is the main requirement, and then new data can be obviously classified based on this training data. In unsupervised learning, class labels of training data are unknown, labels are unknown, remember. So, you have only xi, you do not have yi, that is why it is having one set of data. And so, therefore, given set of measurements, observations within EM, our aim will be to establish coexistence of classes or clusters in the data, clusters, the certain set of data coming under one cluster, certain other set of data coming under other cluster, that is what is called clustering. This can be done easily, right? That is called unsupervised learning. I hope you understand now easily. So, let us talk about a little bit more. For supervised learning, for every example in the data, there is always a predefined outcome. For every xi, there is a yi. That is what he is talking about it. In that case only you can use supervised learning, otherwise you cannot use supervised learning. So, for every xi, there is a yi, and I told you yi is called label. Now, models the relations between set of this descriptive features and a target. Okay, what does the models do? Models will try to find a relationship between set of descriptive features, set of xi's with a target yi. They will find out relations between, finally speaking, yx and y. So, examples are classification and regression. Regression is easy to understand. We talk about it now itself, in this class. So, in classification, it predicts which class a given sample data belongs to. It is just like that. Like here I am showing you, like you can see that separation length and what separation cloth, there are some values are shown, and we want to say which class it belongs to, what kind of relationship they have. That is what is called classification. And regression actually find out relations between two, basically independent variable with a dependent variable. It can find out one independent variable with many dependent variables also. That is also possible. So, regression does that, and it does with certain error. In unsupervised learning, there is no predefined or known set of outcomes. Look for hidden patterns. Remember, this is I like these words. Look for hidden patterns and relationship with the data. Here you see lot of data. You can see the clusters, right? There is one cluster here, another cluster there, another cluster there. So, this is what unsupervised learning does. It finds this hidden patterns exist in that. And so, machine learning as a process can be defined in a broad scale like this. What are the objectives? Objective is to define measurable and quantifiable goals. Use this stage to learn about the problems. First you have to learn about the problems, and then that is the objective. So, what you do first to prepare data. So, data has to be prepared properly. It can be either normalized, it can also be either transformed, we can find out missing values, outliers can be removed. These are all preprocessing of data. You can remove the outliers if you want, that is your choice. You can also fill in the missing values, right, which you think can be, and then you can also transform the data from one specific things to other specific things, or you can do normalization also. Many other things one can do during the building of model. Actually, data can be split. You can find out different kinds of features. I talked about it, variables actually, and then estimate performances, evaluate the model, and also selecting. So, once the model is done, you have to evaluate the model using certain kind of accuracy, certain accuracy, right? Accuracy has to measure, right? We always measure accuracy in terms of error. We will see how it can be measured in a very systematic manner in terms of statistics. then only model can be deployed. This is what is the full process of machine learning. And this is again shown here. The first thing is the preparation of data. You will have raw data. Many of the experiments will give you a lot of raw data. I will show you some raw data of my own experiments in the next class, real raw data. Okay, I could not bring today, I will bring and show you that. So, raw data is what is we get from experiments. But in raw data you will have lot of things, like you will have error values, you will have missing values, different scales will be there, dimensionality may be there, and you will have different kinds of problems for data are collected for different problems and many other things. So, that is why you have to transform the data, you have to scale it up, or you have to do scaling, you may have to center, you may have to find the skewness, outliers has to be removed, missing value has to be found out, and we have to add the errors, and that is what is called first phase, okay, in the machine learning, data preparation. And then once the data are ready, then only you can do a modeling. Some model have strict data requirements like scaling of data, data point intervals. Some models are very open, they do not need that. Some characteristic of the data may impact even your model performance. How do you do that? So, basically for training only this kind of preprocessing of data are required. So, to give an example, let us talk about that. All of you know that we use batteries, right? In batteries you have electrodes, and electrodes, between the electrodes you get a potential, and then only some reaction happens, and that is what gives you battery performance. So, important aspects is your voltage and current. So, now how can I connect this material behavior with the output of a voltage and current of a battery? Because you have materials here, you can have different kinds of material present, like a metal electrode, you can have non-metal electrodes, you can have solution, okay, why not? You can have more than one electrodes. So, obviously there will be 2 electrodes, but you can have more than 2 electrodes possible also. So, all these things are my important features. Then I need data for each of them, how they connected with electrical voltage or electrode voltage or current, then only I can build a model. That is the basic concept of machine learning methodology. So, by now you must know that it is basically a computer program which is told to learn from experience with respect to certain tasks. We talked about it, and few important things you must remember. Each records is basically tells us a description of an instance or a sample, and all these data are called sample space. And what are the components which reflects the characteristic of objects is called features. Component means, okay, let us talk about this relationship. I talk about yield strength is equal to K epsilon to the power n. So, here if we have a relationship between this and this, sigma f and epsilon, but there are 2 important parameters K and n that determine the relationship. So, the features are what? Features are K, n and epsilon for sigma f. These are the 3 parameters on which sigma s depends on. These 3 important parameters. Remember, we are not talking about temperature, that can also. So, I will talk about little bit about classification problem later, but let me go back to regression. Regression is something which is very easy, right? And we will go to the board and explain. In machine learning, what is regression? Well, regression is what? It is a statistical analysis. Okay, we are talking about regression. I always start with regression because regression is easy to understand. Regression is a statistical analysis process. Let's down A. Let's process for estimating. So, it is statistical analysis. What is used? It is used for estimating relationship, quantitative relationship, not any relationship, quantitative relationship quantitative relationships among one or more variables. That is what is the definition of regression. It is a statistical analysis tool or process for estimating quantitative relationship among 1 or 2 variables. That is what it is. Okay. And obviously, it is commonly used for what? It is commonly used, you are also using, commonly used to find any kind of quantitative relationship like relationship between stress and strain, relationship between temperature and stress, between a dependent variable y, let us say dependent variable, and one or more independent variable. You remember the relationship of between stress, flow stress and strain rate. This is what is the relationship. So, here sigma is with the stress, sigma epsilon dot is the strain rate, C is a constant, M is also a constant, correct. So, sigma f not only depends on epsilon dot, but it also depends on M and C. So, we are trying to find out here a relationship between a dependent variable sigma f with more than one independent variables, correct. Well, by the way, for a particular material obviously M and C may be constant. So, there in that case it is basically single independent variable epsilon dot, and remember this is true for a particular temperature. As you change temperature, M will change, everything will change, right. We have seen that. You have seen this kind of plots, right, between sigma f and epsilon dot at different temperature. This is a room temperature, sorry, this is a straight line, this is a room temperature, and these are the different high temperatures. So, as you go high temperature, this slope will increase slowly, right. So, this is T1, this is T1, this is T2, this is T3. So, T3 is higher than T2 and higher than T1. So, that is what it is. So, therefore, it is strongly dependent on temperature. So, if I have data between sigma f and epsilon dot, I need to find out a quantity relationship. That is what a regression does. Okay, I hope you can remember these aspects very easily. So, now the question is this: there are different types of regression, like first one is your linear regression. Linear is find a real, this is not a linear equation of the, obviously you can see that, okay. This is a highly non-linear equation. Linear regression is the very simple regression technique which is easy to understand. Linear regression, then you can have logistic regression. We will talk about each of these things separately, because you will be using this regression tool in machine learning toolbox quite a lot. Then you have what? Polynomial regression. Okay. The last two are very familiar with many of you, ridge regression and lasso regression. The problem is many of you heard of this term and used it, but you do not know what does it do. So, these are the different kinds of regression techniques used in the literature. We should know which one is what and how they do it. Okay. So, let us talk about that. So, let us talk about in terms of data. Let us do that. So, I keep this regression relationship on and remove everything else. So, as you know, we will have data, right, what we call a data set from your experiments, from your collection of data, and let us say you have a data set of n samples. I hope you can remember what is the meaning of samples. Samples are instances, okay, and that means for particular experiments how many instances you have done the experiments, that is what is called samples. So, what is it? So, I can write down this is xi where I goes to 1 to n, that is what is called instances. Okay. So, n sample data, and you also have what is that called labels, correct, or we call responses. Okay, but level is better word we use. Let's not confuse. Level is a better word. Levels we are using. Levels are nothing but yi, right, or yi. So therefore, this is both xi and yi are part of this space, sample space. A sample space is written like this in mathematics. Okay. So they are part of the yi, and this one you remember, this is like this. So this sometime in mathematics, this is how it is used. So xi and yi, they are part of the sample space. Xi is your independent things and yi is your levels or values corresponding to each xi, yi is the value. So now what do you want to do in terms of regression? We want to predict. What is your task? You want to predict what? You want to predict value of y for some unknown value of x. Unknown value of, correct. That is what is your task. Your computer must predict the value of y, any y actually, for some unknown values of x. So if we find the correlation between them, then it can be easily done, right? I know the relationship between yi and xi, that is a statistical process, quantitative relationship. Then I can find out value of any y for any value of x. That is very easy. So idea is to find this quantitative relationship. That is what is the basic idea. You have to find out this quantitative relationship between these two. That is what is the main idea. And in the process we can use statistical tools. So let us talk about very simple thing called linear regression. I erase other things. For today's class we will talk about linear regression, because other things will slowly build up. So what is linear regression? Basically it talks about linear relationship which are linear type. Okay. Linear relationship. You must be thinking it is very easy, right? Well, one of the relationship is like this: yi is equal to w plus w1 x1 plus w2 x2. This goes on. So many independent variables x1, x2, x3, you can see xi's, and plus xp. Okay, let us write wp first, others this wp xp plus epsilon I. Okay, and here I goes from 1 to n. Okay, typically I goes from 1 to n. So now what is epsilon I? Epsilon I is unobserved random error. Remember this word, it is a random error unobserved. You have to incorporate that, because you will not find exact relationship between yi and xi's, right. So therefore you have to add this error. A linear equation is very easy. Even this one is also linear. Okay, there is no power, nothing. It is not epsilon to the power square, epsilon q, or any of these x are also not in power, right. That is why it is called linear regression. This is the easiest way to do. So now how do you represent these things in terms of a matrix, because computer does not understand this kind of relation. This is mathematically one can use. Computer does not understand this kind of relationships. So in terms of matrix we write y is equal to x w plus epsilon. Now I will explain each of these things. So what is y? Y is this y1, y2 yi, sorry, yn, not yi, because we are talking of n, remember n samples, right? And what is x? So let us write this relationship here, then we can write down very easily. So y is x, remember x, okay, and y is this, what is capital X? Capital X is this, very simple, x I t, sorry, x1 t, x2 t, x3 t, xn t. T transpose in matrix, okay. That is what it is. So, that is nothing but, what is it? That is nothing but 1, okay, x I 1, x I 2 to x I p, 2 1, x 2 1, x, this is 1 1, x 2 2, this is not I, x 2 2, x 2 p 1, x 3 1, x 3 2, x 3 p dot 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 dot. Finally, what is the thing? Finally, it will be x 1 obviously, and x n 1, x n 2, x n p. This is a matrix, right? You can see it has p versus n elements, okay, p in the right direction, p plus 1, sorry, p in plus 1, and this 1 may not be there, may be there. For simplicity I put a 1, otherwise it will start with x 1 1, x 1 2, x 1 3, x 1 4, like that. So, now what is W then? This W. W is very simple, W1, W2, Wn, and epsilon is exactly same, epsilon 2, epsilon n. So, now we can do this simple solution of this equation, find the relations between y and x, and W is the weighted factor. You can see it is a weighted factor, okay, weighted factor W1, W2, you are putting a weight on each of these variables x1, x2, x3, like that, okay. That is what it is. So, this is the linear regression. Linear regression talks about a linear relationships, very simple linear relationships like that with certain error terms. So, you must be understand now what is nonlinear. Nonlinear can be many things, okay. So, let us stop today for this simple explanation. I hope you can understand that. We will do a lot of this mathematics in the next lectures for each of these techniques, obviously regression, classification, all these techniques we can do a lot of mathematics. So, I stop it here, come back to you the next lecture. Thank you.